Sorry about the delay. Sorry about the delay. Have some technical difficulty, but it should be fine now. Checking 1, 2, 3. Alright, it's good. Alright. Sorry. Alright, so we can start. Right. What we stopped from last time was in section 2.2. Forgot to update this. So we stop at subsection 2, angle of elevation and depression. With respect to the horizontal line, if we're looking up, that angle is the angle of elevation. And if we're looking down, that is the angle of depression. And we have that example from last time. Right. Now we'll go to this. So a forest ranger in a fire tower 30 feet above the ground see a small fire. So I'm just going to draw a picture. So there's a tower. That's 30 feet high. I see a small fire. The angle of depression is 21 degrees. So for the angle of elevation or depression, we're going to have the horizontal line. And the angle of depression is 21 degrees. So we'll look down. And we see a fire. So that is a fire. And that angle of depression is 21 degrees. And the question is, how far is the fire from the base of the tower? Let that be X. Alright. First, the horizontal line and the ground level, assume that they are parallel. So that angle 21 degrees. So is this angle also 21 degrees. So now we focus on this triangle. And that triangle is the right triangle. We assume that the tower is built vertically, meaning 90 degrees up with the ground level. So in this right triangle, we have the 21 degrees here, and the x, and the 30 degrees. With respect to that 21 degrees, x is the adjacent to that angle, and 30 feet is the opposite. So we have the right triangle that have opposite and adjacent. So we just look for the ratio that has those two, and the tangent is the opposite over adjacent. So that's what we use. So I have tangent of 21 degrees, opposite over adjacent. Opposite is 30, adjacent is x. And then we can make a ratio. Right. So tangent over 1 is 30 over x. Just cross multiply. We have x times 21, a tangent of 21 degree, equal to 30 times 1. And then we just divide by tangent of 21 degrees. So we have x equal to 30 divided by the tangent of 21 degrees. Right. So now we just put on the calculator. Make sure it is in the right mode, meaning mode have to be in the degree mode. Right? Degree. And then second mode, we have 30 divided by tangent of 21 degrees. We have 78.2, let's say that. And the unit would be feet. Right. So pretty much that. So usually the application, we're going to draw a triangle. At this stage, it is only a right triangle, and then find out what do we have and what we are missing. We have 30, and we're looking for x, opposite and adjacent with respect to the angle. Then we can just set up the ratio and go from it. Right. With that, we go to the next section, 2.3. Additional applications of right triangles. One is a bearing. Right. Definition: bearing is a measure of an acute angle from due north or due south. A bearing is the measure of an acute So a few things that we need to pay attention to. First, it is an acute angle, meaning it is only from 0 to 90 degrees, and it is from the north or from the south. Let's look at the first example. To have those scenarios. Now, the definition is with respect from also it go from north or south to an angle. So here, whatever smaller, so we can go from north or from the south, and just in case that, make sure that everybody knows that north is up, south is down, east is on the right, and west is on the left. Alright, so that is the standard. So in this case, what we start with is the north, and then in the east direction, and the angle from north is 40 degrees. So in this case, the bearing for this angle, we're going to say it north 40 degrees east. So that is the bearing. Right. And in this case, we start with north, and we go on the west because it's on the left, and the angle have to be starting from north. So we're talking about this angle. If the whole thing is 90 degrees, the right angle, subtract 40, so this is only 50 degrees. 90 minus 40 equals 50, and so we say the bearing here is north 50 degrees from on the west side. That is the bearing. Same thing here. If we start from the north that will be more than 90 degrees, so we don't use that. We have to start from the south, and that is from the south go to the angle 65 degrees. So we say south 65 degrees on the west side. So it's always start from the north or from the south and then go east or west. This is the south, and we go on the east side, on the right side, and south 30 degrees east. Right, so just like that. Now we have an example. I tried to zoom out on the face cam, but I couldn't. So a camper leaves camp and hike two miles due east. And then turns and hike 5 miles due south. I'll find the bearing. Right. Of course, by that we mean the bearing from the original to the final position. Right, so that is the problem. So we start from the center here. Right, first we'll hike 2 miles due east. And then turns and then go 5 miles due south. Now with that, the question is find the bearing. When question like that, meaning that the bearing from the original to the final. So we're going to draw like that, right? So, and like I said, on most of the title is application of right triangles. So we're going to have a right triangle. Of course, right angle will be right here. Right. So what we're trying to find is in this triangle we have a side and a side. We don't know any angle. So what I will try to find first is this angle. At that corner, angle A. So we have a two and then 5. Now with respect to this angle A, 2 is adjacent to it and 5 is opposite to the angle A. So the ratio that have opposite and adjacent That could be tangent. Opposite over adjacent. Opposite is 5, adjacent 2. So we have tangent of A equal 5 over 2. Which is good. Now we just need to find the angle A. To find the angle A, or to find any angle in general, if we know the ratio to find the angle, we're going to use the inverse. Second tangent, so that tangent inverse. Five over 2. Right, like I said, just make sure that we are in degrees mode. And then second tangent inverse, second and tangent, and then 5 divided by 2. Right, 68.2. So that is angle A here, but that is not what we're trying to find. What do we need is the angle with respect to due south or due north. So we really need to find this angle here instead. Let that angle be the angle X. So angle X, the whole thing is 90 degrees. Subtract 68.2. Minus. So if we want to subtract, I will go up, highlight the numbers, hit enter, just copy and paste. So always work with the full number. Do not round off until the very end. I have 21.8 degrees. So in this case, I will have 21.8 degree here. So the bearing is from the south, 21 degrees, 21.8 degrees. On the east side, that is the bearing. Right, so we have that one. Right. Next, I will try to draw instead of writing the whole problem. So first of all, we have a disabled ship. At this point, the bearing from that to the rescue vessel is south 59 degrees east. So we go south and 59 degrees east. So here is a rescue vessel. And the angle 59 degrees. South and east. And the bearing from to the nearest pole is north 57 degrees east. So here, if we go to the nearest pole, that is 57 degrees from the north to the east side. And the bearing from the rescue vessel, the bearing from the port, so this is the port, and the bearing from there to the rescue vessel is 31 degrees south, 30 degrees west. So we go from the south and 31 degrees on the west side. Assume that the rescue vessel is 56 miles from the port. So rescue vessel to the port is 56 miles. And the question is, find the distance between the rescue vessel to a disabled ship. Looking for X. Right. Let's go through the problem again. So the bearing from a disabled ship to the rescue vessel, 59 degrees south, and then 59 degrees east. And then north, 57 degrees east is port. And the bearing from the port to the rescue vessel is south 31 degrees west, and the distance between the rescue vessel and the port 56 miles for the distance between the rescue vessel to the disabled ship. Right, so now most of our problem up to this point, we have to have a right triangle. So where's the right triangle? So look like it's going to be here, but how do we know that? Okay, so first of all, what is this angle here? We know the whole thing is 180 degrees. So if we would take 180, subtract 57 and subtract 59, we have 64 degrees. So that's why it's good. Now, obviously the only triangle we have is the angle D, R, and P. So we just need to find sum of the remaining angle here. Now, we know that this is the transversal of the parallel line. So that 57 degrees angle is also this 57 degree angle is here. Those two angles will be the same because these are parallel lines and we have a transversal. So that also 57. Because of that, the angle we're talking here, it's going to be 57 degrees. The whole thing minus 31. And 26 degrees. Now in this triangle we have 64 and 26. This angle are 180 minus 26. All the three angles add up to 180. So we take 180 minus 26 and minus 64. and we have 90 degrees. And just mentioned before, we need to have a right triangle. Right, so that's good. We have a right triangle. So in this right triangle, we need to just use some of the angles. Let's say with respect to this 64-degree angle, we have opposite and then adjacent. Opposite to 64 degrees and adjacent to it. So pretty much we have the ratio of opposite and adjacent. We did plenty of this, which is tangent. So tangent of 64 degrees is opposite over adjacent. Opposite is 56. Adjacent, don't know. So we just need to find x. So we'll make a ratio. And then we'll just cross multiply x, tangent of 64 degrees, equal to 56, and then we solve for x. So it will be 56 divided by tangent of 64 degrees. Alright, it's in degree mode, which is good. 56 divided by tangent of 64 degrees. So we have 27.3, and the unit is miles. Right, so that's what we have. Like I said, we need to have a right triangle in order to do it. Right, more examples. Related triangles. Related triangles, the plurals, so meaning that we have more than one triangle. So that is involving two right triangle. Because right now we only deal with the right triangle here. Right. So we have the problem on that side. So first, arrange to find the angle of elevation from where he is at to the top of the tower, 28.3 degrees. Right. So we encountered this kind of problem a lot in real life application. Let's say we have a tower. And it is difficult to find the height of a tower, especially if we cannot get to the base. So we have arrangers over here. First, we will look up to the top of the tower, and the measurement is 28.3 degrees. So the first time we look it up, this is 28.3 degrees. Right, and then he takes 50 feet toward the tower. So we'll take a walk. that is 50 feet. And then he will take a look at the top of the tower again. But this time it is 31.2 degrees. And that's what we have. And the question is, how high is the tower? So we're trying to find the height of the tower. Assume that it is 90 degrees from the ground. Right, so that's what we have. So, like I said, this is the typical problem. Usually, like I said, it would be very difficult to find the height from the bottom of the tower to the top, especially if we cannot get to the bottom. Let's assume that in real life that there's the fencing right here. So there's no way we can get inside close to the tower to measure from the bottom up. I see there's fencing here, so we cannot approach it. All we can do is measure the angle here, angle there, and then this. So what can we do here? So usually for some this kind of problem, we put some letters. Let's say we go from A, B, C, and then D. Right. So what can we do here? So we have two right triangles, ACD and BCD. We have to utilize both of them, and we don't have this side at all. So let's say we have two right triangles, right? Let's say ACD 28.3. With this triangle, we don't have anything. We don't know X, and we don't know this side. Then we have another triangle. BCD, we know 31 degrees, 31.2 degrees, and we don't know X, and pretty much that. So we know it's 50 degrees. So that is rather difficult to do. So what we can do here is, let's say the distance BD here, let that, of course we don't know that distance either, but let that be Z. I call that Z because instead of Y, I call that Z. Let's say it look easier to write. So Z. So in that case, the AD here is going to be 50 plus Z. And the BD here is going to be Z. Right? Yeah, still doesn't help. But one thing for sure, we have to use the tangent of those two angles because we have opposite adjacent. So first I will write out for this triangle ACD, we have tangent of 28.3 degrees, opposite over adjacent. And with respect to this angle, tangent of 31.2 degrees, opposite over adjacent. Right? Now, of course, still two variables, x and z, and two equations. So that's actually fair games. Two variable, two equation. So that's good. So what we're trying to do here is, like we normally do, why don't we cross multiply? So tangent of 28.3 degrees times 50 plus z equal to x. Cross multiply, and here we have tangent of 31.2 degrees times z equal to x. Cross multiply, that's the normal thing to do. Now, luckily what we have here is both of them equal to x. So we let them equal each other. So we have tangent of 28.3 degrees times 50 plus z equal to tangent of 31 degrees times 31.2 degrees times z. Now we can just solve for z easily. Alright, now tangent of 28.3 and tangent of 31.2, those are just decimal numbers. So let's get the approximation here. So what is tangent of 28.3? 0.538. Let's use 3 decimal places. Times 50 times z, and tangent of 31.2. 0.606. Just 2 decimal number. Right, multiply them out. First we have this number times 50, multiply them out, 26.9, and that times z, and then subtract this to the other side. So pretty much we have this number subtract this number. When we highlight the number, hit enter, it is like copy and paste, and we have that. So we have 26.9 on the left hand side equal to 0.067 z. And to solve for z, we take 26.9 divided by this number. So z equal to 26.9 divided by 0.067. Right. Notice that I will not divide by this number. I just go to the calculator, highlight the number, hit enter, divided by, highlight that number, hit enter. And about 400 fit. So that's good, very good actually, but it's not what we are asking for. We know the distance z now. So now we go back and let's draw this triangle for one more time. 31.2 degrees. We have 400. And then x. Now we can find x easily. Tangent of 31.2 equal to x over 400. Cross multiply. So we have tangent of 31.2 degrees and then times the 400, that number, have 242.7 feet. So this problem is extremely important. It is very nice where we try to find the height of anything where we cannot approach the base. Let's see if there is an electric fencing right here and you cannot get past the fencing, then how do you measure the height of a tower? This is one way to do it. First of all, we measure the angle of elevation from that point and then move a distance and then measure another one angle of elevation again. In that case, we can measure the tower, which tower actually get close to the base of the tower. This is about half time, so let's take 5-minute break. We continue at 2:05. Try to fix that. Oh. Yeah. Okay, that's good. The test will be posted on Thursday. Just one more thing though, before we continue. I remember I said at the end of the semester I will ask you the list of the note that you take, and this is one of the things that we ask. The first one is the proof of Pythagorean theorem, section 1.2, subsection 2c. The second one is the related triangles. Section 2.3, subsection 2a. Right. So at the end of the semester, I will ask you the list of the notes that you've taken, including this one. So I'll keep you updated before the semester end. I will send out the list of all of this. Right. Don't worry about this. Looks like we are behind schedule, but I will go very slow on the first 6 chapters, and on chapter 7 we have to do something off. I mean I will do something offline. The video will be offline, so you watch that at your own time. In that case we can catch up. Right. Next example, B. So I only draw the pictures. So we have a tower. That is 150 feet high. So we have a tower that is that high. And when the sun is directly overhead, so the sun is straight up overhead, and we catch an airplane and this shadow. So because it is overhead, an airplane here, the shadow will be straight down. And with respect to the tower, when you look up to the airplane, look it up, that is 67.4 degrees. And looking down to 8.1 degrees. Yeah, and this is the tower. Looking up to the airplane, 67.4 degrees. Looking down is 8.1 degrees. And the question is find the height of the airplane. The question is, what is the height of the airplane here? Right. First of all, when we look at this 67.4 at 8.1, this is not the right angle, so we're not going to use that right angle. The right triangle we have is, of course, we're talking about this. Let's say this point is H. So we have two triangles. T, H, and then A. 67.4 degrees. and then we have this triangle. (8.4 degrees), 8.1 degrees, T, H, and S. Alright, so those are the angles and the triangles that we have. Alright, what do we know? If this is 150 degrees, 150 feet, this is also 150 feet. Right? By the way, both of these are TH and TH, so let that be Z. Yeah, this is Z. Right? So we have Z and then 150 here. And suddenly here we can find that the remaining distance. Let that be Y. So, in this triangle we don't know either Z or Y. That doesn't help. For this triangle we know Z and 150. So suddenly we're going to use this one first, and then we're going to use this one. So this is the first step that we use. Now with respect to angle T, we have 150 is opposite, the Z is adjacent. So tangent of 8.1 degrees is equal to opposite over adjacent. And again, make a ratio, cross multiply, times Z times tangent 8.1 equal to 150. So we solve for Z, 150 divided by tangent of 8.1. So still in degree mode, 150 divided by tangent of 8.1, and we have 1053.95. So now we have Z. Next, we go to this triangle, and with respect to that 67.4 degrees, we have opposite Y and Z is adjacent. So opposite is Y, adjacent is Z. So always tangent is opposite, adjacent. Write that over 1 and cross multiply. So we have Z times tangent of 67.4 degrees equal to Y times 1. Also we have Y equal to Z tangent of 67.4 degrees. So this one is Z times tangent of 67.4 degrees. And we have 2,531.96 feet. So that is Z. I mean, that is Y. And finally, we asked to find the distance X, which is Y plus 150. So X equal to Y plus 150. So we have that number plus 150, 2,681.96 feet. So that's what we have. And with that, we go to chapter 3. So up to this point, all the measure we have is using the degrees measure. Again, hit mode, make sure it's in the degree mode. The next section we will go to the radian measure. It's radian measure, sorry, it was right there. So I'm not going to write down everything. It's a definition on the right hand side, but this is how we define 1 radian. Right, so first we're going to draw a triangle. All you need is a pen and a pencil. I would prefer a pen and a pencil. Just hold like this, very steady. So this cannot be moved. So as long as you maintain this distance fixed, just hold that on paper, and all you do is rotate the paper, never rotate your hand. So if you have a fixed center, yeah, so that's close enough. So just hold that very steady. That distance is always constant, and hold the center, rotate the paper, do not rotate the hand, and you have a very decent circle. Right. Of course, a circle, what we're going to have is from the center to the edge. To the edge, and that is called the radian. I mean the radius R. And for and if we have the angle between two radius, between two radii, that theta is called the central angle. The angle between two radii and the vertex at the center. Now, the way we define 1 radian is this. It's not going to be easy, but so it's about here. Right now, so we have the radius, plenty of the radius. Now, if we rotate the radius so that the length here, I'm talking about the length of an arc, this one. We rotate so that the length of the arc is the same as the radius. If we have that case, then this is said to be 1 radian. So 1 radian is the angle so that the radius will have the same length as the arc length. That's the way we define it, and later on we will find out that it's about 57 degrees. Right, we'll do that in a minute. But what we have is, in general, if we have the central angle and the arc length is S, then the central angle is given by the lowercase s divided by r. Right, so what we have, S is the arc length, the length of an arc. R, of course, is the radius, and so that's what we have. Now, here's the problem. The unit for the arc length, usually, let's say, feet. The unit for radius also feet. Feet over feet, it cancels out. So the radian here actually has no unit at all. But what we do know is this. If it go 1 revolution, what is the arc length for 1 revolution? So if we go 1 complete revolution, that is going to be the same as the circumference. Of a circle, right? If we go 1 complete revolution, that is the same as the circumference, which is equal to 2 pi radius. And that arc length, let that be lowercase s. Right? And then the angle correspond to one revolution. We're using that formula. Now, always theta equal to the arc length divided by the radius. Now we know the arc length is 2 pi r. The radius is also r. That cancels out, equal to 2 pi. So from here we say the angle corresponding to 1 revolution is equal to 2 pi. So what we have here is 1 revolution equal to 2 pi. The unit will be radian. And that is equivalent to 1 revolution will be 360 degrees. So that's what the unit we have. So 1 revolution is equal to 2 pi radians, or 360 degrees. Now if we divide by 2 on both sides here, or we say pi radian equal to 180 degrees, we usually use this a lot more than this. So meaning that pi radian is equal to 180 degrees. By the way, radian is just like a unit. Instead of degree, we use radian. Some examples. Definition, and now here's some example. Convert from radian to degrees. This, I mentioned this many times already. Whenever we write an angle, make sure from B it is from degree to radian. Whenever we write degrees, make sure there is a little circle, the symbol for degrees. Right, 30 degrees. How do we go from 30 degrees to radian? Right, what we have is this ratio, right? Pi radian equal to 180 degrees. So we can say we do not want degrees anymore. So we're going to put degrees at the bottom, 180 degrees. And then we put pi on the top. By the way, the radian is a nice unit. We don't need to write. Or in physics, we should say radian is unitless. Meaning that we don't even need to write the radian here. It's kind of understandable. If there's no unit, we can just roll the radian. Alright, now we don't want the degrees. We put degree at the bottom so that degrees cancel out. We have 30 pi divided by 180. 30 divided by 180, that is 1 over 6. 30 divided by 180. Convert to fraction, 1 over 6. So we just say pi over 6. And that will be good enough. We don't even need to write the radian. And if we write it, it's okay too. Like I said, radian is kind of nice. We can put it in or take it out whenever we want for a measure of an angle, that is. Negative 210 degrees. Once again, we do not want degrees, and we use that ratio, so we're going to put the degree at the bottom and radian on the top. Degrees and degrees cancel out. Negative 210 pi. We cancel the degrees, right? And negative 210 divided by 180. It's negative 7 over 6. And then we put a pi either that or pi on the top. It doesn't matter. Like I said, we don't even need to write the radian. Right. I think one more will be good. 75 degrees. Once again, we do not want degrees. That's why we'll put 180 degrees at the bottom. Then pi on the top. Degrees cancel out. 75 pi divided by 180. And convert that to fraction. 5 over 12. So 5 pi over 12. Again, we don't even need to write radian for the unit. Right, so that's simple enough. The conversion factor is pi equal to 180 degrees. If we don't want degrees, put degree at the bottom. But if we do no degrees, if we do 1 degrees, we put that on the top. Convert from radians to degrees. Right. Once again, we're going to use pi is equivalent to 180 degrees. Pi radian is 180 degrees. So first, if we have pi over 6, and what do we do? So we start with pi over 6. And we're going to multiply by the conversion factor. Right. Now, this time we do 1 degrees. So we're going to put 180 degrees on the top. And then pi radian, or just pi. Like I said, the radian, we can put it in or take it out anytime we want. Now the pi and the pi cancel out. We have 180 degrees divided by 6. Now we take out the radian as I want, and that will be 30 degrees. Two. Negative 3 pi over 4. We convert to degrees, so we're going to put degrees on the top, and then pi radian at the bottom, or just pi, doesn't matter. The pi and the pi cancel out. We have negative 3 times 180 divided by 4. Right, negative 3 times 180 divided by 4, negative 135 degrees. Now it's very important that we should write degrees whenever we need degrees. Right. Next, we should get familiar with the trig values, the sum function values. In terms of radian. Alright, so we have that table on that side too. Trigonometric function values. we have the special values of 0, 30, 45, and 60, 90. Okay, those are typical. Right, that table. Let's go with degrees first. 0 degrees, 30, 45, 60, 90, 180, right. Now we go to equivalent in terms of radian. Okay, so 30 degrees. Now if you multiply by pi, what is 0 degrees? Of course, is also 0 radian. So what is 30 degrees? 30 degrees multiply by divide by 180 times pi. Okay, 30 degrees multiply by pi divide by 180, cancel out the degrees. 30 pi over 180, so pi over 6. Uh, 45 degrees cancel the degrees. 45 pi over 180, cancel out, pi over 4. And 60 degree, if we do that, will be pi over 3. And 90 degrees, pi 180, cancel out, 90 pi over 180, pi over 2. Right. I make it a little bit darker so it's easy to see. I hope. Right, that's better. And 180 degrees is a pi. 270 degrees is 1.5 or 3 pi over 2. So we have those values. Right, now the side values. Now we'll go back to the hand. Now instead of writing those angles, now we write the angle equivalently. 0 radian, pi over 6, pi over 4, pi over 3, and pi over 2. So again, 0, pi over 6, pi over 4, pi over 3, and pi over 2. And then the values as we go. So cosine, sine is the angle from the right fingers on the right. So we go from 0, 1, 2, 3, and 4. So the way we memorize this, or I memorized it back in the day, was square root of 0 over 2, which is 0, square root of 1 over 2, which is 1/2, square root of 2 over 2, which is just that, square root of 3 over 2, just that, square root of 4 over 2, 2 over 2 is 1. So the way we memorize 0, 30, 45, 60, and 90 degrees. 0, pi over 6, pi over 4, pi over 3, and pi over 2. The measure, square of 0, square of 1, square of 2, square of 3, and square of 4 divided by 2. So that's what we have. Those are the values. And cosine is pretty much this, but in the reverse order. Square of 4, 3, 2, 1, and 0. So sine is the finger on the right, 0, 1, 2, 3, and 4. And cosine is the other opposite. So 1, square 3 over 2, square 2 over 2, 1/2, and 0. Right. How about 180 and 270s? Right. Pi. Now, for this one, usually if it is a multiple of 90, we do it differently. 180 degrees is right here. That point, if we choose x to be -1, y is 0 because it is on the x-axis, and r is equal to 1. So then we just have the ratio of sine is y over r, y over r, y over r is 0, and cosine is x over r, so -1 is 0. And 270, this is 180, 270 is going like this. X is 0, y is -1, and then r is 1. We can choose any numbers. Actually, if it is over here, x is certainly 0, and y we could choose any negative, like -5, and then r is that distance is also -5. I mean, but it's positive. R is always positive. But instead of choose like random -5 or 5, I choose -1 and 1, and the ratio will be y over r, -1 over 1, -1, x over r, 0 over 1, 0. So we have those special values. Right. We will do this in section 3.3, but for now just go to arc length. Forgot change the section, so we just finished 3.1. Now we go to 3.2. Forget to change that. Please remind me if I forgot to change the section on the title at the bottom left. When you watch it live, it doesn't matter, but it will be useful for those who watch the replay. Right. So again, just have the hand here. 0, pi over 6, pi over 4, pi over 3, and pi over 2. Equivalent to 0, 30 degrees, 45, 60, and 90 degrees. Right. It goes without saying on the test, I'm talking about the test, like we have 3 tests. I cannot enforce the closed book, closed note. So in that case, it goes without saying you can use your note. And when you have something like this, it will be very useful to reference to. Anyway, section 3.2. Arc length. Right. Right. I'm just going to write that the formula for the radian measure. Of a central angle. That intercepts an arc of length S is. So what we have is a radian measure angle theta and an arc length S. The relation is theta equal to S over R. Of course, we talked about this on the previous section, in section 3.1 already. So actually, I try to draw an arc, so we don't have to draw the whole circle, just an arc. So hold that steady. And rotate the paper, never rotate the hand. The hand is steady, just rotate the paper. So if we have radius or rotate an angle theta have to be in radian, then the arc length is given by that. Because when we write like that, we can also say S, the arc length is equal to R times theta. Example. A circle has a radius of 18 inches. I'll find the length of an arc. Intercepted. by a central angle of 210 degrees. So my physics professor usually, when we have any work problem, so the first thing we do is just write out all the numbers and the unit. So that is the radius of 18 degrees. 18 inches. Radius is 18 inches. Find the length of arc. We don't know that. The length of an arc, right? The length of an arc on arc length is S. We don't know. We know the central angle of 210 degrees. Right, so that's what we have, and that's what we're trying to find. Perfectly fine. Right. So formula S equal to R times theta. That easy. Except the most important here, of course, in the formula, in the definition, we said it has to be in the radian measure. So we have to convert that into radian. So to convert to radian, meaning that we do not want degrees anymore. So multiply by pi divided by 180 degrees, because we need the degrees at the bottom. So the degree will cancel with that degree. So 210 divided by 180. When I do the calculation, I always leave a pi out of it. So 210 divided by 180. So I can write it as a fraction. 7/6. And at the end, we stick a pi to it. Right, so we have that. The radius is 18 inches. And the measure of the angle is 7 pi over 6. So 7/6 times 18. That number times 18. Again, I leave pi out of it. It'll be 21. And at the end, I will stick a pi to it. So this is 21 pi. The unit will be inches, because the arc length is going to be inches. Same as the radius. If we want to approximately 21 times, to get pi, we hit second, and that simple. Right? Once again, second and a half. So approximately about 65.97 inches. Two. I have to write it out. Use 3,960 miles as the radius of the Earth. And we have miles cities. In Nevada is 440 miles north of Boulder, Colorado. Find the difference in latitude. So I'll try to draw a circle here, and both of these cities, as most of the United States, be on the northern hemisphere. So only need to draw upper half. Okay. Right, so we have, right, so we know the radius of the Earth. (3960), and we have, by the way, this kind of cross section, Mao City, and then Boulder. Actually, this is on the north of each other, so I'm doing the cross section of the Earth. That is distance is 404 miles on the surface of the Earth. 404 miles. That distance. Right. Of course, on the surface of the Earth, when we go up, that will be north, that will be south, and the question is find the difference in latitudes. So the question is, so we have the latitude, and the difference in the latitude is actually just measured by this angle here. Because the latitude pull around. Oh, it's that longitude. I always got them mixed up. Let me check real quick. So we specify the north and the south position, so that's good. Right, so we have the radius is 3960 and the distance, so we have in this form radius 3960 mile, 440 is the arc length, what will be the angle? Right, so we have the arc length equal to r times theta. So to solve for theta, it's going to be s over r divided by r on both sides. So 440 divided by 3960, and that is about exactly 19. By the way, that is in term of, that is the theta is equal to 1/9. As always, measure of arc length have to be in radian, so this is going to be in radian. So that's good, but usually the latitude or the longitude, we talk about the degrees, so we have to change this to degrees. So theta equal to 1/9. If I want degrees, put degrees on the top and radian at the bottom. 180 divided by 9, that's 20. (180) divided by 9 pi, 9 pi So that gives us 6.36 degrees. Right. So if we look it up, we can see the difference in the longitude, in the latitude between Mars and Boulder is about 6.36 degrees. Right. So that is the arc length. We run out of time, so I think we have to stop here. Right. So we will finish this section. Actually, we should be able to finish 3.3 and 3.4. Those sections we'll go over them quickly. So finish chapter 3, chapter 1, chapter 2, chapter 3. That will be on the first test, and I will post the first test right after we finish on Thursday. And I mentioned this many times. The deadline for the test is at the last day of the semester, so whenever you take the test, that will be fine. It will take that at your own time. It will be on my MATLAB. Of course, I will tell more about that on Thursday. Anyway, I'm going to end the stream here, and once again, I apologize for the technical difficulty at the beginning of the date. I should not update the software right before I use it. Have a nice day. So see you on Thursday.